Hey, good evening, everybody. If you've never been here with us before, my name is Mr. Nielsen, Joshua Nielsen, and I've been an APES teacher for about 6 years or so, almost seven, and I've been an AP reader for this will be my fifth year. And tonight we'll be covering, bam, there it is, renewable energy. Basically, I'm going to go over solar and a few other things here. Hey, we got a couple more people. Thank you, Dakota. Hey, Hugh. All right. So, without further ado, hey, Adam. All right, y'all. So, like I said, tonight I'm going over a renewable energy source. This is part of Unit 6. If you guys have gotten there. If not, then it's a preview near the end of Unit 6 right now. But, of course, before I begin anything, just want to tell you thank you for being here. And, of course, follow us on all of our social medias at Think5able. We're on the Twitter, the Instagram, and of course on the YouTubes. We're a bunch of great teachers and student streamers that are here just to help you guys hopefully understand a little bit more about certain subjects. All right, so here is what I'm going to cover tonight. I'm going to talk a little bit about solar energy, then wind energy, and then energy conservation. Okay, hopefully you know a little bit about these, but if not, then hopefully I'll be able to teach you a little bit about them tonight. All right, so I like to start off everything with a little question. So here you go. Which country is the largest producer of solar power? Germany, United States, Japan, or China? Little tap in the little chat window. What do you think? Okay. Doesn't matter if you're right or wrong. I tell my students all the time, I don't care if you're wrong. I don't care if you're right. I just want to see that you're trying. And if you are accidentally wrong, we'll fix you. If you're accidentally right, we won't have to fix anything. All right, we got one vote for Germany and we got one vote for the United States. 2 votes for the United States and 1 vote for China. All righty, the actual answer is, as of now, it's actually China. China is the largest producer of solar power. Massive amount of land space. They are an up-and-coming nation, and they are, well, they've been up-and-coming for quite some time, but they have the largest amount of solar power in production. I believe the United States is second, followed by, well, I don't remember if it's Japan or Germany, but they were close. Big brain. Everyone's got big brains. It's bigger than that chimpanzee right there. All right. So what exactly is solar energy? Just to put it in like a tiny little, one sentence phrase here. It's solar is the radiant energy, and we're going to convert it into electricity. Either it's going to be active, which is electricity, or you're going to turn it into passive energy, which is heat. And so basically, these are the things that you guys kind of think of when you're thinking of solar energy. Little solar panels. That one right there charges a very old cell phone. Solar panels on the sides of the buildings right there. Of course, I was first introduced to them in the solar calculators. They were super popular when I was younger, and that was a long time ago. And then nowadays, you have even like the tiny little solar garden lights, which I convert to do other things. All right, so how many of y'all, please tell me how many of y'all have ever seen the solar panels on the side of a person's house? Not just like a business or anything like that, but a person's house. Excellent, yeah. As of right now, they're starting to get very cheap, okay? Much, much cheaper. But there are some problems with solar power, okay? Actually, at one of the junior highs I used to teach at, they have a 5 kilowatt solar panel outside of the junior high. I was one that was actually tracking all the data. And you can see, of course, on bright days, it makes lots of energy. And on cloudy days, it makes just a little bit. But even then, it still makes some energy. It was really neat. But I was the only one that did it. Don't processes all of sunlight. No, there is an efficiency thing with them. They are not as efficient. They are getting better, though. As of right now, they're between 12 and 22% efficiency, I think. Only in richer areas? Well, you can actually find them in, well, I'm not saying like the big solar panels are on top of the houses, but even like those tiny little ones, I can get one from there's a place called Harbor Freight. I get one for $140 that could actually probably take care of my Chromebook. It has enough power that it can charge up my Chromebook for $140. It's not bad. All right, so I do want to show you this little image right here. Okay, this is the amount of, it says direct normal solar irradiance. Basically, as the sun shines down, it would be perpendicular to the surface. So as the sun shines, it keeps rotating to make sure that's always at a 90-degree angle. All right, so where do you see the majority of this solar irradiance being located in our United States? Southwest. Yep. Very much so. One, it's closer to the equator, so therefore we're going to get closer to the that 90-degree angle with our tilt of the sun and all that. So yeah, you're going to see a lot of it down there in the southwest regions. Okay, and they also shows capacities of basically their towers and all that. It's too hot in Texas sometimes. Yeah, not right now. I'm in the northern section of Texas, and we have a snow day today and tomorrow. We got about 6 inches worth of snow. We're not used to that. It's very cool. Yeah, Dakota, I remember you're a little bit farther south, and I think y'all are just getting some sleet. We've got the big snowflakes. Anyway, so solar energy. And actually, heat is not much of a concern because, well, he is going to be concerned with some of your solar panels if you accidentally melt something, but there are different ways that you can release heat and all that from them. But yeah, we're going to see the majority of all the solar energy used in the southwest region of the United States. But if you look on the East Coast, all those little blue dots show that there are solar panels, there are solar stations of some sort actually gaining energy. And it's because they are highly populated over there, so therefore it makes sense to put them out there. Even if they get a little bit of sunlight, it's better than nothing. It's just you're going to look at the cost factor. Is it worth the cost for the amount of energy you're getting? Okay. Sorry, I have a potato chip stuck in my gums right there. All right, so let's talk about passive solar energy. What does passive mean? I know it's said on there heat, but think about the word passive. What exactly is passive? Help me out here. What is your definition of passive? All right, I've got potential. Subtle. All right. I really do appreciate everyone participating. Thank you so much, y'all. Saves me from talking to myself. In this case, it's similar to those. Basically, we are not using anything. It's just kind of almost, if you want to think of it, natural. I don't want to quite use that term, but natural. So in this case, our solar light is converted directly into heat, and there's no use of any mechanical machineries, nothing like that. We're not able to collect it or to store it. It's just, again, it's just heat. One of the things I've always wanted to do is this. This is a solar oven, a solar box cooker. It is a box covered inside with tin foil and usually have a glass plate over top, or you can use plexiglass, but it might bow. Oh, you made hot dog? Oh, awesome. Great. That's awesome, Hugh. Yes, passive in this case means no machinery. It is no help in this case. Yeah, so I've always wanted to build this with my students. I wanted to have it basically as a little lab, but when it comes up in my year, it's a little too cold for these solar box cookers. But there's a lot of varieties of them. I've seen basically a tube, probably similar to the hot dogs. There's a tube that you slide the hot dog in, and then all the solar radiation is basically the sunlight is just concentrated on that area. They're absolutely just super cool. But there's another one that I've always wanted to do, and I like to do little neat things around my house. I try to cut corners and save money. So this is one of the things I've wanted to do, and I've been kind of turned down on it numerous times. because I just want to hook up the stuff myself. This right here is a solar water heater that you would place out either on your roof or out in your yard. And then you would hook it up to your water heater in your house. And so the idea of this is the sunlight is concentrated on those tubes as you have water being pumped through them. And then the water then goes into your hot water, your heater itself, and it just constantly is heating the water. And it takes very little energy to actually pump the water out to that hot water heater. Like I said, I was just going to get like things from like, big box stores and all that. And that's why I got turned down. Had I found a legitimate place just like this one on here, then I'm quite sure my wife wouldn't have much of a problem with it. But there's lots of different things. Even I've even seen in camping supplies where you have just a black bag, a black plastic bag that will and I know it says we don't have any collection or storage, but it's temporary. You heat up the water in that, and that turns it into a camping shower. So again, in this case, we're not able to store the heat, even though the hot water is going to be taken to the hot water tank. That is a different set of storage. It's not going to be stored on this. And in this case, it's not really machinery because there's nothing that is doing any conversions. Okay, it's just pure hot water. Oh yeah, it's highly interesting. I've seen, instead of tubes like that, basically it's a 4-foot diameter spiral of just black tubing that just goes around, and you lay it out at a slight angle, the best angle for the sun at that area, and you heat up the water. I've seen lots of examples of this in Hawaii. Yeah, the black's going to absorb the heat, so you definitely want to use a darker color so it can attract that heat as much as possible and transfer it to your water. Obviously, if you use white, you're just going to shine all that sun off of it, in which case it will not, deposit its heat. I hate to use that. Conductor would work as well too, most definitely. You want to stay away from anything that gets too hot, because then you may accidentally melt whatever your water is going through. Or, water's going to go all over the place. Alrighty. Any questions about passive solar energy so far? Anything I can help you on that? Or do you have another example of a passive solar energy device that you could share? Going once, going twice. Black t-shirts. Yeah, black t-shirts, black cars. We definitely do not have black cars in my family here in Texas because it will just totally heat up during the summertime. We try to keep everything white or very light colors. If you ever want to warm up your car, you'll notice, yeah, we'll all melt there, Dakota. You'll notice that on a lot of the window shades that you put out, one side is reflective and the other side is a dark color so it can absorb some of the heat, like in wintertime. It'll help warm up your car. Again, that's a form of passive energy. The tinted glass in this case helps not to absorb the heat, but to kind of reflect some of it, allow less light to go in. But with the window screens, it will actually get through the window first and then hit that window shade, the dark colored one, and then that'll help to heat up the car. The tinted glass is basically right there on the glass and it won't go out. Why does black attract heat? It doesn't actually attract heat. It will actually, I'm really not good at the physics stuff. I'm just a biology guy, really. I'm trying to remember exactly what it is. I cannot even make anything up that sounds halfway decent right now. I do apologize. I'll get back to that. Isn't so well, light is not opaque either. It will bounce it off. So I will look that up here. If you guys have a math question later on, I'll look up that. Let's see. It doesn't reflect light as well. That is correct. It'll absorb. It just doesn't reflect as well. The heat. It's basically kind of like the black holes. It is able to take in light, and very few of those photons and all that are able to bounce back out. So when they go in there, think of it like tape. It gets stuck to there, and heats up the material, whereas light, they will bounce right off. Okay. Oh, thank you, Hugh. Hugh put out a nice little version of it in there for us. Thank you very much. Appreciate that. I have not actually had to think for quite some time. So, like I said, we had a snow day today. And yesterday wasn't much better. All right, let's go on to the next part here. Active solar energy. This is what you guys usually like. Well, snow is nice. Believe me, we had lots of fun making snowballs and throwing them at each other. My dog thought it was hilarious today. She's just a puppy. So active solar energy is, again, we're going to convert this into electricity. So passive we had is heat. Active we will do as electricity. Okay. Here we are going to use machinery or electrical equipment, all that. We are able to, in some form, store it or collect it for later use, kind of like in a battery. The one most people understand are the photovoltaics. Generator, yeah, you can store it in a battery to be used later. You can also use it to basically run a generator. Solar farms. Now, solar farms come in two different flavors. There are steam generators, and then they also can store it as salt. They'll melt the salt and use that heat to create steam later. Excuse me, I have a little basic image, and I'll talk more about that here in a moment. So here is just a normal photovoltaic, what we call a solar cell or a solar panel. Each one of those tiny little squares is a solar cell, and then together is a panel, and then most panels together are known as the array. All they do is they take in, what are the other types there are? For the active, this is basically the majority of the two that you would actually see. It's just how specifically they will create the electricity. So what these ones will do is the electricity goes in, bounces off of a material which emits a few electrons. The electrons, again, are basically electricity, and they'll flow through the wires, and that's how we get it. The other one right here, this other picture that just popped up, this is what we call a solar. This is another form of the solar farm. This one is a solar collector. So all those are tiny little mirrors that are shining up onto that central tower. You can see they're all in a circular area around that tower. And let's see, I see more solar panels like that in the rural areas. Oh, very cool. Okay, so now what this light will do is it will collect at that central point, and it is insanely bright, and it takes all the heat with it too, because it just bounced off of mirrors. And there's enough heat there that it can actually melt salt, or it can be directed to immediately boil water. Now, the salt one, that's kind of like, it's known as a salt battery. So you can melt the salt, and it can retain its heat for quite some time. So that will be, collected and stored elsewhere. And when you need to use that heat, like at nighttime, in order to create electricity, these solar farms, again, will heat up water, turn it into steam, and then basically they power a steam engine, which is how the majority of electricity is produced. The salt storage is so that they can do it at what we talk about off-peak times, or basically your night times where there's not as much solar light. Okay. An example that was in a really terrible movie called Sahara with my wife's future ex-husband, Matthew McConaughey. So, all right. Any questions about active? As far as I understand, they will not ask you how a photovoltaic will produce electricity, other than the fact that it converts sunlight directly into electricity. So you don't have to worry about those specifics. But they may ask you about a solar farm similar to the one on the left side there. Now, where would you find these? Yeah, you're going to find a lot of them. In this case, yes, active is machinery, passive is not machinery. Dakota said he sees a lot of these solar panels that are more in rural areas, and it's because you need a lot of space. Like on the right-hand image, just that one array that's on that post, is maybe enough, maybe for a small household. So because in rural areas like in Texas, Oklahoma, and Wyoming, and all that, you have lots of large spaces. You can put more panels out there, and you're not really going to disturb hardly any of the ecosystems. Okay, so now the one you see, the big solar tower right there, you definitely need a very large area. You can see it covers uh, multiple acres right there. You're probably looking at 40 or 50 acres. And so because of the amount of heat generated off of those mirrors, you don't want that to be near a lot of housing developments either. Okay, sweet. Alrighty. Now, as with everything, there's always pros and cons. Okay, now this was supposed to pop in one at a time, but it didn't, so I'm going to just give them all to you at once. So, benefits: we don't have to pay for the sun. All right, great thing. It comes free with your existence, so we're good on that. If you're going to get solar panels for your house, there's lots of little rebates that you can get depending on the areas you're in. But normally a solar panel for your house can be paid off in 15 to 30 years, which is the normal life expectancy, one, of the solar panels, and two, that's usually how long you're paying for a mortgage when you're paying for a house. So by the time your mortgage is done, normally the price of the solar panels are also done too. Now, some of the drawbacks to that is, if you don't get as much sunlight, or if you have lots of cloud cover or basically tree cover, you're not going to produce as much electricity. So the payoff time is a little bit longer. Another benefit, of course, you can use it almost anywhere. Even though we saw the majority of that is in the Southwest Texas, Southwest United States, there's sunlight throughout the entire planet. You can have sunlight anywhere. So even these little solar panels will work literally anywhere. I have a couple of solar panels. One is charging a small little battery for my light in the backyard, the security light, and I have those little garden lights. I've rigged them up to have a little bit more light in a little neat little way. I saw it on Pinterest. So literally, you can have these almost anywhere, and even that's a solar calculator. It works inside. You don't even need sunlight. You just need to have a little bit of light on those. And of course, how is efficiency both? Okay, so as I said, the efficiency is getting better, but it's still not where we really want it to be. We would just be incredibly happy with it getting between 30 and 50. But right now, we're, depending on the age of the solar panel, I believe you're maxing out between, maybe 20 to 25% efficiency. And so it is getting better. The technology is getting better. And as more people purchase them, it's getting cheaper. So that's why efficiency is on both. It's not the most efficient, but it is getting better as we improve our technology. And technically, that's the same with all of them. They're all getting better as we improve the technology. And of course, scalability. If you have more panels, you can power up more things. You can produce more electricity. Now, drawbacks again, cloudy days. And of course, it doesn't work at night. So if you have solar panels on your house and that's the only way you're charging it, or you're basically using electricity for your house, if you don't have a array of batteries to charge up during the daytime, you won't have any electricity at home at night or during cloudy days. That goes along with the expense of the panels. They're rather expensive, but so are the batteries that you have to purchase in order to charge so that your house has, again, electricity. They can be very similar to like a car battery. And the cheapest car batteries I've seen are about $50 or $60. And you need an entire bank of these. So you're going to look at, for a small to medium home, probably upwards about 15 to 20 batteries. Of course, you don't want to do this by yourself. You want to have it done professionally. Now, the manufacturing of the panels, it is getting cheaper, but that's not where the problem lies. It's the amount of toxic materials that are in the creation of it. And when you're digging up for these materials, some of these toxic metals can accidentally leak into the surrounding environments. And that's one of the biggest drawbacks to the solar panels. A lot of people will say, well, solar panels are great for electricity, but they're a detriment to the environment. And this is what they'll key in on, is because of that. It's the possibility of chemical leaks when they're producing the panels. And then farms can be negatively impacted in desert ecosystems because of the heat. Also, the panels are going to be quite low to the ground, so you can't really have like grazing cattle. Definitely can't have any, crops in or around those solar panels. So this area has to be solely devoted to just the solar panel. Okay. Any questions? Thumbs up, thumbs down. You good to go? Oh, my neck. I don't know. Is there a thumbs up? We got a yep. Awesome. Thank you. There is a thumbs up. Thank you. Tanya, Dakota. Sweet. Adam. Alrighty, let's rock and roll. Moving right along. So, my next question for y'all. According to the map, which region of the United States is the most likely to have the highest number of wind turbines? Pay very close attention. Okay. California, Southwest. If you look on the map, you see the speeds are right there. They're the highest in the blue areas and lowest in the green areas. The West in general, West Coast in general. Yep. You're right. Now, do you know which state has the largest amount of wind turbines? California's a good guess, but it ain't the right one. It's Texas. Texas has the largest amount of wind turbines. I probably live about 30 minutes from close to 800 wind turbines anywhere. So yeah, we have the most. Now, we don't have the most in the entire world. Spain's really why in Texas. Actually, it's going to be West Texas, where there's very few people out there and lots of open lands. You can see right there, right through the middle of the U.S., all those deep purples. We have lots of high winds that can fit right through there, but we don't have a lot of people that live there. Now, do I think wind turbines are ugly? No. As an APES teacher, I don't. And as like a person who lives around here, I don't think so. I think they're great because I know what they can produce. They produce, rather clean energy. Okay, and I say rather because, again, just like solar panels, the whole manufacturing cost is in there too. No, I don't think the wind turbines are ugly, but I do live near a Air Force base, and there is a ban within a certain radius because they can affect the radar systems. They can block scenery, and that's what a lot of people do not want. They say that the sound of them and the fact that they block scenery are one of the problems with the wind turbines. I'll tell you right now, I've never been up close to one, so I don't know much about the sound. But I also know that they're incredibly tall, and so therefore it doesn't block much scenery. Would they put that on the test? Would they put what on the test? I'm sorry. The amount of sound produced from a wind turbine? They may mention it as as one of the drawbacks, as a negative to wind turbines. If you've ever asked what are the positive negatives, that would be one of the negatives, is there is some sound to it. Yeah, I heard about the AP English had a wind turbine question. It was hilarious. I was like, it was really neat that they had a science question for us. So, alrighty. It was horrible. I'm so sorry to hear that, Dakota. All right, let's talk about wind energy. We have literally been using it for thousands of years. It is one of the oldest forms of energy that we have been using. I can think of the sail and stuff like that. Nowadays, we have our wind turbines. Literally, all it is moving air causes a rotation in this wind turbine. So we're going to take moving air, which is kinetic, turn it into mechanical energy as the rotation, which will then produce electricity. This is one of the oldest forms of wind turbines, as that windmill would spin and turn, it would turn a shaft, and you would actually grind up grains underneath. So again, wind energy is not always electricity. It's a form of power, and that's why we're talking about wind energy and wind power. Why isn't it referenced as a mechanical energy? In this case, that wind turbine is, because we're not producing electricity, and that's what we're usually looking at. Is when we're talking about all these different forms of energies, we basically go to the electricity portion of it all. Now, I really like talking about wind energy. Unfortunately, I spent a lot of time talking about solar, but these are three of the wind turbines that you would actually see. And you would not have to like memorize their names or anything like that. But that modern one right there in the middle, that's what you'll normally see. They usually have three long blades standing 50 to 100 feet up in the air. The Savonius one, which is on the left-hand side, takes up a lot less space. So you can see that you don't need as much of the space for those huge... oh, I'm sorry, Hugh. Take care, man. I didn't even see it. All right, take care, and I hope that was helpful for you tonight. So that Savonius one, like I said, rotates on its side, and so you don't need as much space. And it also can be rather low to the ground. You don't need that. Same thing with the other Vought. I see the one on the right, mostly on farms. That one was basically designed on something similar to like a weather vanes and stuff like that. What you'll notice is instead of a large sheet like the one on the far left, the one on the far right is more like basically airplane wings, very similar to that of the one in the middle. There's one more I want to show you, and I'm going to flop my screen here real quick. This one. What is it based on? This is one of the newest ones. This is actually based on the Nautilus shell. So this was actually designed by looking at nature. Really cool. So a lot of the different ways wind can actually cause this one to spin. This one I 3D printed after I first learned about it. So the wind coming to, basically coming right out here at my face can turn it right here as it pushes in it. If you look right here, if the wind comes directly at it, it will also, as it goes through the spiral, start pushing it and rotating it around. Normally it's on some sort of gimbal, so kind of like what I have in my hand, so it can rotate with the wind. And then, of course, as it spins, just like the normal wind turbines, there's a generator. So you're going to have basically magnets rotating with around near the magnets, and that produces electricity. Okay. So yeah, this is the newest one. They actually make these. They're from one side of the way, the other side is about 5 feet, 3.5 to 4 feet up and down there. They actually make them from houses. I first learned about it about 4 or 5 years ago. I thought that was one of the neatest ones. It is able to basically power enough for a small house. It's wonderful, and you don't need a lot of wind. That's the cool thing about these. You don't need a lot of wind. In fact, actually, too much wind is a bad thing for wind turbines. So let's go into that, the benefits and drawbacks here. Again, just like the sun, wind is free. It's non-depletable. It's not going anywhere. We are not going to get rid of wind. It's very clean, okay, unless you have dust in there. And actually, that's one of the problems with the solar panels is if they get dusty, it reduces their efficiency. Wind turbines, you don't have to worry about that. You can put wind turbines on grazing lands. The ones that are around me are on cattle ranches. And so they just need a space about, I want to say about 40 feet by 40 feet or so in order to have the tower. It goes up, and then cattle can graze all around it. Those wind blades are not anywhere close to the cattle. And so, again, you can graze cattle there. You can even grow crops there still, too. And you can actually put these offshore. There's lots of different forms that they put offshore. So they're away from people. Again, there's not that eyesore thing. and you can just have the basically the pipes with the electricity, the actual lines, the electrical lines, come back to the shore and help generate electricity for the people on the islands there, or even I believe Denmark was recently 100% renewables. Most of it was from wind. Last couple of years or so. At one point in time, it's it's a really neat little efficient system. Now, one of the problems, lots of people have been saying that, of course, you're going to have lots of bird deaths, lots of bat deaths, and they'll get confused. The bats will get confused by the spinning blades, and so therefore they will run into them and crash and die. There is a powder coat that you can put onto the windmill blades that will basically tell the bat that it's too big, run away or whatever, it flies away. It's a little bit more expensive, and a lot of the companies are not quite doing it yet. Same thing with bird deaths. They get caught in migration patterns or whatever. But there's been plenty of studies that show that cats are actually the largest killer of birds by far, and not windmills. But again, there's lots of different studies. You have to see which ones. Intermittent winds. There's not always going to be wind. Sometimes there's windy days and there's not windy days. So you have to basically make sure that you are in a location that is going to have consistent winds. And then the speed limits. If the winds are too fast, they will have to turn off the windmills, the wind turbines themselves, in order to protect them. If you're going too fast, the possibility of the whole tower shaking or vibrating, even the blades themselves could be ripped off, and you don't need a lot. So they have to keep the turbines shut down in higher winds. And I can't remember exactly what it is, but I want to say it's, really want to say it's about 15 miles per hour that they really want to turn them down. And then, of course, we got into the idea of the aesthetics. They block the view, they block scenery. There's the possibility of noise. Noise is in part of the aesthetics right there. Basically, it's what looks or feels or good or happy to people. So the noise is going to be in that aesthetics portion of it. All right, Carla, welcome here. Carla said that she read an article that said that another drawback for windmills is that their old blades can't be recycled. Yeah, I just read that too. I just saw something like that. Yeah, they can't be recycled. Parts and pieces of them, but the majority of it cannot be. And the blades themselves are on a 10 to 15 year lifespan. So where I'm hoping that we can fix that recyclability problem. But also think of it this way. Look at the amount of space that those wind turbine blades would actually take up versus the amount of ash from coal and the possibility of radiation leaks, which is very low, by the way, from nuclear power plants. So, guess not. Again, the noise and the looks of the windmills, that's part of the aesthetics. Okay. Alrighty. Last part here. This is the part that nobody wants to worry about, because we're going to get into the math here in a bit. All right, so personal question here. What is the average time spent in a shower for men or women? Just on an average, what do you think? I'm not asking how long you spend in a shower, just what's the average for men versus women? I do this in my class too, so very surprised. I had one girl said that she usually takes a 20-minute long shower. And I was just like, wow, your water bill must be huge. And then another girl says, well, she likes to take a bath, but she always wants the bath to be hot. So she'll fill up the hot water in the bathtub, pull the plug, and then just turn the hot water on until she's done with her bath. And I was like, wow. Oh, I was just like, why are you in my class? Seriously, though. Hopefully you're going to learn something. All right, so some of the numbers are going to come up here. 5 and 10 minutes, 10 and 25, the same to 15 and 45 for men and women. All right, so here's what I have. This is a quick little Google search. On average, men spend about 7 minutes in the shower, and women spend 9. I think that was a rather low one. on the women. I myself spend 5 minutes in the shower, and it's because, look, nothing I have to worry about up there. So I don't have to worry about hair. Oh. Yeah, so yeah, you're basically average there, Dakota. Okay, so why do I talk about this? There's lots of different ways that you can alter your behaviors in order to conserve energy. That's what we're going to talk about right here, energy conservation. So at home, this is what I do. This is not a picture of my house, but we don't use our dryer unless it's for socks and underwear, stuff like that. All our clothes are hung out on the line, except for today where it's snowing, and we will air dry. I'm not using any electricity unless absolutely have to. And it's actually better for my clothes too. They will not shrink because of the heat of the drying process. Why don't we use hydropower as much? Hydropower can only be used, near large enough rivers, and it's because you have to build the dam, or if you don't build a dam, you're going to have just a turbine inside the river itself. And unless the river is big enough, you're not going to produce nearly enough energy or electricity for the population. It's good on a small scale if you have smaller rivers, just for like charging of a phone or something like that. Dams are also expensive, like Carla says, and of course they impact the ecosystems. Yeah, I think that's supposed to be talking about next week though. And it can be efficient. Again, all you're doing, you're just spinning a turbine, and we're not going to push all the water over to that turbine. So some of it still has to have fish. All right, so energy conversion at home. Little things that you can do. Okay, think of it this way. A little bit goes a long way. You can adjust your thermostat. As of right now, my house is set at 68, but normally it's at 64 in the winter and 78 in the summer times. And our summers can get up to 105 around here. So, of course, you can adjust your thermostat. In my house, we happen to just wear more clothing in the wintertime. The suggested temperatures for the day is about 70 degrees Fahrenheit, and at night is 65 to 67 degrees Fahrenheit. That is the recommended temperatures. In fact, actually, they just came out with new ones. Always keep it at 70? Yep. Yeah, we don't do that in the summertime because, once again, I don't like spending money. So that's, unless my wife says I really have to. Your health temperature says 64 at night? Hey, doing that good then. My wife does have a fan that goes, but I have no hair on my head, so I get cold. So I have to have it a little bit warmer. All right, talk about water conservation. Again, shorter showers. Okay. In the Antarctic, the research stations down there, you have literally just a small amount of water you're allowed to use per day. So when you have to bathe, you will basically get yourself wet. You will turn off the water. You'll lather up. You'll try to get as much of it off as you possibly can. And then you'll rinse off because you only have very small amounts of water because you're, in Antarctica. Despite the fact it's covered in ice and snow, it takes energy to melt that to produce water out of it. So shorter showers, I don't even there's that lathering and rinse part. I don't even water my lawn, which we'll talk about here in a little bit. Low flow toilets and shower heads. You'll see that there's even toilets that have the 2-button system, one for literally number 1 and number 2. That's how they go. A lot of schools are converting to those. You can have low flow shower heads. The one I was looking at has these pebbles inside of them. What is a low flow toilet seat? I don't think there's a toilet seat, but just a low flow toilet itself. Is that it uses less water. It's designed specifically so that you have less water that goes rushing through it. And so just a little bit of water is able to flush all the feces all the way down. So it uses less that way. Or again, it has the 2-button, just enough for urine and just enough for the poo. You have a 2-button one? Cool. Yeah, Japan has been using those for quite some time. In my family, we go by this rule. If it's yellow, let it mellow. If it's brown, flush it down. So it's we have to basically stop that rule when we have guests over to the house because they don't know it. But every time you pee, you're peeing into absolutely pristine, clear water, and then you flush it. So even with a low flow, that's like 1.5 gallons of water for your couple of ounces of urine. So we've instituted the if it's yellow, let it melt. So if you come into the bathroom, you're the first one to pee on there, you let it sit. If you're the second person and there's pee in there, you'll pee and then you'll flush it. So basically, it's 2 pees for a flush. If it's brown, that means someone forgot, and then someone's going to be yelled at. So every time you poo, you flush it. There's not a scent odor problem because we keep the lid closed, and we also use basically chemicals to help reduce the smell. But enough about my weird house. Let's talk about energy efficient appliances. If you see the Energy Star on things, it is certified by the government to save electricity or energy of some form. Newer refrigerator models are way better than the old ones. The washing machines, you can have high efficiency washing machines, so you're going to use less water, less electricity. I have seen that in the appliance stores. Yes, look for the Energy Stars. There's even computers that have Energy Stars ratings on them. The only thing I didn't put in here is I didn't put on like switching your type of light bulb, because the majority of light bulbs nowadays are not those incandescent bulbs. They're going to be LEDs, and they're going to be those compact fluorescent lights. And a lot of people would be upset about both of those as well. They don't produce nearly as much heat, but the compact fluorescents have a small bit of mercury in it. And the production of the LED lights also, again, has some toxic chemicals in their production too. So, but yeah, that's the other things we need to a little bit do at your house. And it's really hard to find the incandescent bulbs now. Native landscaping. Once again, I do not water my front or my backyard. It's all native grasses. I keep it mowed and just let the amount of rain that normally comes down on my house water it. But I do have 2 large rain barrels, up to about 800 gallons worth, that I fill up, and I will use that for some of my trees, some of my bushes, and if I need to, I can put it onto yard. So I reuse rainwater, which in some places is illegal. So make sure if you're going to do that, you check your local city ordinances about collecting of rainwater. Okay. We are trying to do that for our APES project. Oh, very cool. If we have a few minutes, I wouldn't mind hearing about your APES project. Oh, my back. Okay, so large scale, what can we do? Large scale, thinking big. So this is going to take a lot more. Fuel economy. Basically, cars have been getting better and better in their gas mileage, but we kind of had a little setback in the last, I want to say, 7 or 8 years. It hasn't been as efficient. I've been driving my Prius. It's a 15-year-old model, and I'm still getting like 36 or 37 miles per gallon. But most cars nowadays are only getting 35 miles per gallon. Okay, so that's one of them. Think big. Look at fuel economy for vehicles and the type of fuel. Carpooling. School buses. That's a form of carpooling. Hydrogen fuel cells. That would be beautiful, but it's difficult to recharge them. If you think about that too. Oh, thank you for joining us today. Public transportation, buses, trains, airplanes. I know they're not the most fuel efficient things, but for carrying a large amount of people for large distances, airplanes are really good. So are trains. I think trains are the most fuel efficient form of travel, but I could be wrong on that. Hybrids and battery electric vehicles. Again, your hydrogen fuel cells are really cool. Again, it's just kind of difficult to charge them. Motorcycles are fuel efficient, but they do produce more. They produce more gases, some more of the emissions from a motorcycle. I happen to have one, and I still only get about 36 miles per gallon on that. Trains can burn coal. There are some electric trains, but the amount of coal that they burn versus the amount of weight that they can pull, it's they are the most fuel efficient on that way. But yes, there are lots of trains that burn coal, or if there are many more that are diesel engines. In fact, actually a diesel car engine is more fuel efficient than a normal unleaded car engine too. And then green buildings. What I have right here, that bottom left-hand side, that is a passive solar house. In the summertime, which is the top circle, the top smiley face is my son, you notice that the overhang on the building right there blocks out the majority of the light, so it's not going to get into the house. And then in the wintertime, when the sun is lower on the horizon, it is just able to get underneath that overhang, get into the windows, and warm up your house, which, again, it does work in all locations or at all latitudes. Saw a picture of that. The heat passes right through the windows. Yes, because windows can do that. You can also warm up the walls, and you have convection currents within the house as well. There's another one similar to that. But the main idea here is to reduce the amount of heating and electricity from air conditioning. So finding ways that you don't have to use as much energy, but use what's around you anyway, naturally anyway. Insulation is another big thing for both heating and cooling. There's lots of earth homes built out of natural materials, mud, stucco, actually built into the sides of hills. So you have natural insulation and consistent temperatures too. We have, I believe France, Paris specifically, has passed a law about 5 years ago that said any new construction has to have a green roof. So you are actually growing grass on top of the roof, which will help either reflect, or basically you're cutting down on the amount of heat produced by the roofs. And you're also able to collect rainwater. And some places are actually growing like vegetables, a small little seedy farm up there too. Space efficiency as well. Yes, most definitely. Alrighty. I think I had one more on here. What am I missing? City design. Most European cities are very compact. You'll find everything in that one little area. Whereas here in the United States, I grew up in Houston. It took me 10 minutes just to go to the grocery store to get milk. Everything being spread out, you're spending more gasoline trying to get places, coming back. So the idea of keeping everything in a tight-knit area, you'll see, again, it's that space efficiency idea too. And that's why you'll have like neighborhood grocery stores or the neighborhood gas station or even neighborhood schools to keep things so that you do not have to travel nearly as far. And that helps on the wear and tear of roads as well. Alrighty, I've only got 5 more minutes left. Not sure if you really want to do fun with math, but this is a modified form of the FRQ from 2018. I modified it so that teachers don't yell at me for using the actual numbers. I'm not trying to give you guys answers. I'm just trying to give you the idea of how to do this math. In the energy unit, there's lots of math, and you're going to see the majority of math questions based on energy or something similar to it. Okay, energy or pollution, waste. So here's my question real quick. Excuse me. You have a windmill project. It has 400 windmills. They each have a capacity of 2 megawatts. Each turbine costs $1.2 million. The demand in the area is to be about 3 times 10 to the 5th megawatt hours per year. So they're going to throw a whole bunch of numbers at you, but look at what the question is. Calculate how much electricity in megawatt hours the wind project needs to generate per year to provide 70% of the annual electrical demand of the service area. So the first thing you need to do is figure out what your units are supposed to be at the very end of this. We use dimensional analysis because even though you're allowed to use calculators now, you still on the math FRQs have to show your work. That's very important. If you do not show your work, you're not going to get any credit for math problem. All right. So if your work is correct, then you're more likely going to punch in the correct numbers. So what are the units I'm looking for on here? It says calculate how much energy or electricity in megawatt hours. Exactly. Megawatt hours, and the other part was it per year. Okay. to generate per year in order to provide 70%. So that's what I'm supposed to end up with. So I'm going to start off with one of those numbers on the top or the bottom. So megawatt hours, I have 3.0 times 10 to the fifth. And if you don't understand the scientific notation, that's 3 with 5 zeros after it. Where did the 70% come? In the bottom portion, it says, in order to provide 70% of the electrical demand. So basically, they said, these are your windmills. This is how much power you produce. Basically, how much is 70%? Because the area apparently just needs 70% of that energy. So that's where that 70% came from. They're saying, what is 70% of this maximum number of 3.0 times 10 to the fifth? So that's what we're going to do now. We're going to multiply it by that 70%, 70 over 100. Because we don't need all 100% of this energy, because that's the maximum it can produce. We just need 70% of it, because that is relatively what we're going to need. Again, according to the question right there. So if you're to multiply this through, so the cost was just there to confuse you. Actually, so this was like a 2 or 3 part question. I'm only doing a portion of it, so they could be referenced in the next part. I'm only doing the first one because I don't want to hurt people's brains with lots of math today. But yeah, the price would be in another question, along with the number of turbines. So even if they did give you lots of information, just pinpoint what the question is asking for. On your test, you're able to circle things and underline them all you need to. So do that in your document. Circle. It says calculate how much megawatt hours. I would go up there, find where it says megawatt hours, circle that, so that I understand this is what I'm looking for. Okay. So like I said, this is a multi-part problem, but I only put a portion of it in there. So the answer actually comes out to 21 times 10 to the fourth. How do I find that? I'm glad you asked. First, I got the 70 over 100. I just yanked off the 0 on both the top and the bottom. So that's 77 over 10. 7 times 3 is 21. So that'll give me 21 times 10 to the fifth. Because again, that would be 21 and 5 zeros after that. But I'm dividing it by 10. So I just take off one of those zeros. So I have 21 times 10 to the fourth megawatt hours per year. So if you set it up just like you have on the screen right here, even if you don't get the right answer, you can still get a point for the proper setup. And of course, units are highly important. Without units, you are not going to get credit. I always put units on your setup and put units on the answer. And make sure they're the right units too, okay? Once again, if this question or this answer was to be used for another question later on, if you had the wrong answer here, they will not basically have cascading failure. They will take your wrong answer and recalculate for the next problem if it had to be used. Ooh, I had lots. Okay. My time is almost up, but I can spend a few more minutes here if you guys have any more questions, comments, concerns. I do want to say, again, thank you for joining us tonight. My name is Joshua Nielsen. Thank you. Again, remember us at Think5able on the Twitter, on the Instagram, of course, on the YouTubes. I can stay around for a few minutes if you guys have questions about anything else that I can help you with. Am I streaming next week? Actually, no one's picked up next week, so I don't know. But if no one picks up in the next day or two, then somebody, more like I will do it. I have no problem with that. We're going to talk about renewable energy again, I think, next week. Thank you all for joining us. I hope I'm helpful. I'm hoping I'm not too boring. That's the worst thing, is a boring person. Not as many dad jokes this week. I do apologize for that. Let's see if I can't get better. Somebody is going to stream next week. I just don't know who it is. We have a couple of people, so we'll figure it out soon. But of course, look for us. And are there any questions? Okay, yes, your project. Thank you, Tony. In your project, we have to create an energy and water efficient house. We're creating a hydro-powered house that runs on rain, and the water is collected at the bottom. Very cool. Very cool. Thank you. Well, every teacher is interesting in some way. I just have to have lots of acronyms like ADD, ADHD, and all that. So you can turn the dam sideways. Oh, yeah. I hadn't thought about that. I'm very sorry, Dakota. but try to find something interesting. There's always something interesting, some way that you can look at stuff. In my life, I try to find ways to incorporate little Lego minifigs. Or the wolf is my favorite animal. There's nothing wrong with coaches. Coaches are good people. My wife is a coach. She coaches softball. She's almost as crazy as I am. Well, Tanya, good luck on your project. I hope you have fun. I hope everybody does well. And I will sign off if there's no questions or anything else. And hopefully I'll see you next week, or hopefully at least you'll be here next week with our presenters. And I will say good night and I'll bid you adieu. Take care, ladies and gentlemen. See ya.